when you're in the CNC lab, we're going to be working with a variety of different tools as well as tool holders. And this video is just going to kind of go over some of the really quick loading and unloading procedures and the advantages and disadvantages of each tool holder. So the very first one we're going to look at here is just your simple drill Jacobs chuck. This is probably the most universal as well as the easiest style of tool to use. It's very quick to load, and chances are by now, if you've ever used like a cordless drill, a drill press, maybe a mill over on the vertical milling machine, you have seen this style of holder. Right now I'm currently using one of our tooling carts, which is really nice because they all have an area where you can load and unload your tools, which is really handy. When we are loading a tool into this, obviously we have 3 jaws. This rotates. We have the little serrations on the top, and then we use a chuck key in order to tighten our tool. So it's as simple as putting your tool in, rotating this by hand so that your drill is snug between the 3 jaws. You want to make sure that you are contacting on all 3 jaws, not on 2, or else your drill is going to be wandering around and going for quite the wild ride. Your hole will also not be the nicest of round or look proper. And we need to use our chuck key. We insert it into our hole, and we want to make sure that we tighten this really well. So the reason we want to make sure this is tight is, again, remember, we're not the ones who are going to be feeling the amount of pressure that is pushing on this drill when it is machining. We really don't want this drill pushing into our holder because it's not tight enough. So where this drill holder is really simple to use, the biggest downside of it is that they're really not that accurate. So if you were just drilling a fractional sized hole, maybe for a bolt hole or a reference location, this would be suitable. But if you were trying to drill with any real accuracy, this would not be the best style of holder. For what we're doing, for the most part, it will work. They are quick, they're easy, and they're convenient. But again, in industry, this is not a very common style of holder, at least not in my opinion and where I came from. The next style of holder we're going to look at is a collet style. This, I think, is, in my professional opinion, is the most accurate as well as the most commonly used in industry. The way that it works is we have a nut, and then we also have our body, which is tapered. So right now, obviously, we don't have anything in here that will hold onto our tool. And I'm just going to set this down really quick, because the reason it's called a collet holder is because we have these here, which are called collets. So where this is more accurate, the problem is they are a little bit more expensive because you have to buy a collet set with it. And you will see that all 3 of these collets are different sizes. When you are choosing the proper collet, we need to find the right size for the tool we are using. So for example, if I want to put this tool into a collet, this one is too small. If I want to see if this one will work, obviously it is too big. And sometimes there will be a little bit of slop, and the collet, when it compresses, will make up for that, that diameter size. In order to determine whether your collet will reduce enough in size, what I like to do is I like to put my drill in the actual collet, and then I wrap my hand around and I squeeze with my fist. And if I can still move this drill in and out really easily, that means that this collet is too big in diameter. I do have the proper size. Here it is here, and you're gonna see that it nicely slides in. And as soon as I tighten this with my hand, I can't pull this out. So I know that this will be a good size and a nice fit. So students always make, and I understand because I was in your shoes at one time too, it's which order do we put our collet, nut, and our tool fully together. So the first thing we're gonna do is we're gonna take our drill and we're gonna set it aside. That's the last piece that we really wanna focus on. The very first thing we want to do is take the correct size collet that we have, and we want to insert it into our tool, or into our nut. So the best thing that you want to do is, I always like to put it on an angle and just kind of push it up and in, and you will see that the collet will stay in place. If it doesn't, it may not. I mean, of course this one won't fall out, but sometimes you'll get them where they won't sit in the nut. The best thing you can do then is just flip it upside down, and then gravity will just hold it into place. So now that I have my collet in my nut, the next thing I want to do is I want to take my tool body, and I'm just going to rotate this in. So, I mean, a couple of turns, so that way this won't fall off, and it will also lock your collet in place. After I have that, that is when I take my tool, and this is when I want to insert it into my entire, my assembled tool. So I'm just going to set this in. I'm going to rotate my collet, and again, you can see this is fairly tight. I can pick up on my tool and this won't slide out. I need to make sure that I tighten this. It's very important, and it's the exact same as my Jacob's chuck. I want to make sure that this is tight because I really don't want this tool pushing in. So again, you're going to have this spanner. This spanner fits over the notches in the collet, and you just want to kind of give it a couple, taps with your hand, or a few good pulls to really ensure that this is tight. You're also going to notice with my spanner that all 4 teeth are engaged in the collet. What I see a lot is this, where students put one in and you turn. That is incorrect. All 4 of these should engage with the nut of the collet. So that would be our second tool. So the next style of tool holder that we're going to be inserting a tool into is an end mill holder. These here are generic and will only hold certain size end mills. So with our Jacob's chuck and our collets, where we have multiple size ranges available, only one size of end mill will be able to fit into this holder. So these, I would say, are just as accurate as our collet size, but they're even more pricey because you only are able to hold on to one tool, or one tool size, with each holder. So it is a end mill holder because it has a set screw on one side of the diameter. And the reason for that is, I'm just going to take this set screw out for right now, is because most of our end mills have a flat on them. So I'm not sure if you can see that cut out of the flat. I'll rotate it so hopefully you can see that a little bit better. But you'll see that there is this flat here, and that is so when we tighten our tool into the holder, our set screw will tighten on that flat and prevent it from either rotating or sliding up and down. So the best way to load an end mill into an end mill holder is we want to, first you need to make sure you have the correct size, and you'll see how firm of a snug, or how snug of a fit that is to put this in. So we want to make sure our flat is going to be facing our set screw. I'm going to slide the end mill down and in until I can see the flat through my hole. And now I'm going to tighten my set screw using an Allen key. So a lot of times what I like to do is I like to just tighten this kind of, fairly firm by hand. And a lot of times you'll see your end mill moves up or down and rotates a little bit when that flat lines up perfectly with the end mill. So then I'm going to put this back into my holder to make it easier for me to tighten. And I just want to push down on that end mill to make sure that my set screw is going to be really pushing in and against the flat on that end mill. So again, really common in industry to use end mill holders. This one is for a 5/8 end mill, and only. You would only use this for a 5/8 end mill. So again, you would have to buy an entire set of these to hold different sizes of end mills. And our last style of tool holder that we're going to be using is a tapered shank tool holder. So it looks very similar, and I'm just going to grab this different one here. It looks very similar to our end mill holder, other than there is no set screw around the outside diameter. And another really clear giveaway that this is for holding a tapered shank drill is because it has this slot in the taper of the holder. The reason it has that, and you may be asking yourself, what is a tapered shank tool? This here is an example of a tapered shank drill. As you can see, I have my drill with my cutting edge here, and you're gonna notice that this is on a taper, so we can't use any other style of holder to hold onto this drill. Another clear indication that it's a tapered shank is that it has this tang here at the very end. This tang prevents any rotation in case the taper of the tool and the taper of the holder lose that permanent contact and this wants to slip. So this is kind of like your added insurance. So again, we know that this will be a tapered shank tool holder because of this slot. And this slot is there for the tang of our tool to align inside this holder. Now I do have two different styles of these. And the very first one is this style here. It is smaller, and in fact, the taper of this holder will match the taper of this drill. So if I were to put this in, you'll see, I don't know if you can look down and visually see that this is now tight in this holder. This would work perfectly fine, and I'll show you how you properly would load this tool into the taper, but I don't want to use this one because what may happen is you have a tool holder and the taper inside is bigger. So when I put my drill in, obviously that is not going to do us very much justice. And in fact, if I turn this over, you'll see the drill will fall out. What we need to do is we need to use a tapered sleeve. And this sleeve will match this size of holder. And again, it has a slot here, which represents where our tang will line up. And then it also has a tang of its own to locate inside the holder. So loading these is really quick and really easy. We put our tool in and we rotate until our tang falls down inside this slot. So right now I can't really rotate that very much. Again, the taper is really what's holding everything tight in. And then a lot of times what I'll do is I'll just come right over to this surface here. It's a really heavy, hard piece of steel. It's really thick. I drop my tool. I like to drop it twice just for added reassurance, and I will not be able to pull this out anymore. Just from dropping it, those two tapers have now wedged themselves into one another, and this drill is really tight within this taper. In fact, we will need a tool to remove these two pieces from one another. So now that I have the sleeve on my drill, I can take my correct size holder, and again, I have my cutout in the taper, and if I drop this down, and I'm actually gonna put this in sideways, so that when I rotate, you're gonna see both the drill and the tang fall down within that slot. So again, I need to make sure that this is gonna be tight. I'm gonna drop that twice, and again, this taper and this entire tool will now be permanently fastened. Well, not permanently, we can still get this out, but it will be really tightly fastened into this holder, okay? So that would be our final tool assembly that we're gonna be using. So really make sure that when you are loading a taper tool, you are using the correct holder. You cannot hold onto a tapered shank tool with either a drill Jacobs chuck or a collar. One really important thing that I want you to pay attention to when you're working with your tools is the pull studs that are on the bottom of each tool. So these are really important because as you can see, we have two different styles of pull studs. This one here is long and narrow and skinny and tall, and it is a BT40 pull stud. We use this on one of our CNC mills here in the lab, and it's really important that when you are using the machine, which has signage on it and posters saying that it uses a BT40, that first you are using the proper cart, which is also labeled with all the BT40 tools, and that you are only using this style of holder in that machine. The reason is because a drawbar will come in, it pulls on this pull stud and pulls it up into the machine. And so if you are using the incorrect version, it will jam in the machine and it causes a lot of headaches and issues. And You know, for us taking 2 seconds out of our day to look and ensure that we're using the proper pull stud can save us a lot of headaches. So where this version is a BT40, this style here is a Cat 40. And again, if we look between the two, you'll notice that this is much shorter and much fatter than the BT40. So again, our other 2 mills use this style of pull stud. It is really important that when we are done with our tools, we make sure to put this back on the proper cart with the other Cat 40 tools. And we're also only using this style in the 2 mills that use the Cat 40 pull stub tool holders. So one really important thing that I want to bring up is obviously this is a place of learning, and with learning comes breaking things. I understand that because at one time myself and any one of your practical professors was also in your shoes, and chances are we have broken things throughout our career. We understand that mistakes happen and accidents happen, and you know, some tools may get broken or probes may get bent. We are learning and we fully understand that. All we really want to ask of you is that if you break anything, please let us know, because that way we can order and replace whatever was broken. The big thing is that we learn from our mistakes if anything does happen, but again, we can't fix it if we don't know. So rather than just kind of sneaking the tool out in your bag or throwing it in the chip bin, make sure to bring it to our attention, all right? We really appreciate it.